Welcome to a space where ideas spark curiosity, questions ignite answers, and inspiration transforms lives. This is Mind Alchemy, your destination for unlocking potential in everyday life.
Welcome to this live session on AI and machine learning without coding. Join us in this episode. A seasoned expert in machine learning shares how to kickstart your AI and ML career using free and no-code tools. This tutorial is perfect for anyone, regardless of background, to understand machine learning basics and its real-world applications. With insights from both academia and industry, our guest makes complex concepts accessible to help you future-proof your career in AI. Subscribe now, hit like, and share with your friends and colleagues to stay ahead in the AI revolution. Master AI effortlessly with our channel, covering Python, free AI tools, data engineering, generative AI, cloud fundamentals, and more, perfect for beginners, researchers, academics, and professionals. Subscribe now, hit like, and share with your friends and colleagues to stay ahead in the AI revolution. Let us begin the session now.
Okay, so now this teachable machine, once you click on this teachable machine, you will reach this particular page where you can click on get started. I'm giving you one particular example with image data. Let's say this is an image project. If I click on this and open this, you see by default it is providing me with two different classes. So what essentially I'm going to do is I will be uploading some images here from my computer, and then I will test that whether those uploaded images are able to predict a particular category in real time or not. Let's see. I'm uploading an image from this data folder, image test, where you will see that there are certain categories like this. So let's say I'm uploading three different categories. Let's say I'm uploading the human category. This is what is the human category I have uploaded. All right. So this is now uploaded for you. Then I will upload another category. Let's say I'm going to upload a category named monument. So if I upload this monument category here, so these categories, so each of the categories, as you can see, is having 10 different images. I can add one more class here, and I can go on adding classes. So this is the class 3, where I'm going to have another kind of category. Let's say the category be buses. Okay, so this is the third category which I have chosen. All right. So why shall I leave the last one, the last category? Because I have only 4 categories here, just for the purpose of example or the demo. So let us see what is the 4th category I'm left with. And I think I'm left with the sea beach category. So this is what is the sea beach category, and I'm uploading here for you. So now you see there are 4 different categories, each category consisting of 10 different images, and you're having 40 total images. Okay. What I would do is that I would now train the model. But before that, if I would like to do the parameter tuning, I can do so. I will reduce this to 4, in fact, because the training set is much smaller. Batch size here is 16, and the learning rate is by default it is like this 0.001. And let's start training the model and see that what is the implication of training this kind of a model. So once I click here, once I click on the train model button, so it is preparing the training data. So let us see what happens once it prepares the training data. So it is having 40 different images from 4 different categories on which it will be getting trained. So now, as you see, for the 4 different epochs, it will be training the data. Okay, so it is now trained. So you see, my webcam is on, and as you see, as I'm showing my face, it is showing that class 1 input is having the maximum probability. What is class 1 here? It is human beings, right? So I am a human being. Hope the participants do not have any doubt about that. So class 1 is having the maximum probability. Class 2 is 26%, which is much lesser. Class 3 is even less than 19%, and class 4 it is not visible actually, but then that is also somewhat around 19%. So it gives a conclusion that this fellow who is in the video cam is a human being. So you see how in real time it is being done, right? Now, if I would like to flip my camera, let's see if something happens. If I, crop my image a bit, so is it like that? Some probability increases or decreases. Let us see if I hit the crop, and you see the probability is there, and it is correctly identifying it as an image. Okay, image of a human being. So now, if you would like to export the model, you can export it from here, and then like if you would like to have new projects and open project from Drive, you can also save the project from here, and you can also download the project file from here. So there are so many things which you can do with the help of this particular tool that is available online for you for free. So once you are doing that, and once you are using this particular tool, you may be willing to see what's under the hood. So if you click here, what's under the hood, you can get many different things. What are those things? Let us see. Let us have a look. So you can have accuracy per class. You see, this is the accuracy. Class 1 accuracy is 100%, and class 2, class 3, class 4 is 50% accuracy, right? So this is what is the accuracy for testing, right? So you see how the accuracy has varied, and this is being shown here. You see the loss for each of the 4 epochs is also being mentioned here in this graph. You can also take out this graph and can put this in your presentation or wherever you are doing this assignment. I mean, for whatever reason you are doing this assignment, you can have beautiful graphs and things like this. You can also have the confusion matrix. So calculate confusion matrix is giving you these results, right? So these are the different sorts of confusion matrix elements which you are having. So you are having everything here online. So this is what you have done without a single line of code. As you can understand, and you can feel and see that how easy it is really if you are willing to do and willing to solve a problem. Next, I will show you another software which can do this task without coding. The name of that software is Vika. Okay, this particular software is available for free. So if you go here to the internet browser and click that Vika download, you will get the link for this software. Okay, so here it is there, Vika 3 data mining software from the vika2.ac.nz. So this particular website is developed by the University of Vika2, and you can just click here and can move on to the website of Vika data mining software with open source tools, and you can download it from here. So now if you click the download button, you can go to the download page, and you will find the different versions of Vika which are available here for Windows, for Mac, for Linux, and for all the this operating system platforms. You are having Vika, and it is having a size of the exe file of 118 MB. So you can choose if you are in Windows. Since I'm working for in Windows, I will be choosing this particular version. If I click here, it will be downloaded for me. Okay, so this easy it is to download Vika and to install from the exe file. Once you do that, you will encounter this particular window, because a folder will be created for you, and this folder which is being created for you is lying here. That is, in the program files on the C drive, you will find that there will be a folder named like this, Vika 3 version 8 and 4. So 3.8.4. So this particular version is there, and once you click on this version, you will get all these files. Where if you click on Vika with console or Vika this file, you will be redirected to this particular screen. Okay. So once you are redirected here, so you can do a lot of things with this particular screen. What good things you can do? First, I will show you with Explorer. So if I am now switching on the Explorer for you, what will I get? Let's see, what will I get? Now I am getting this particular window where I can select, and I can do classification, I can do clustering, I can do association rules, I can select attributes, I can visualize, and I can focus. So I'm giving you certain examples. The primary example which I would like to show you here, first of all, is that how to handle missing data. So now let us move on and see a data set which is having a couple of missing data. So let us open here, and in Vika it is supporting two different types of format of files which can be uploaded. One is the .arff file and the other one will be the CSV format or the CSV file extension. So here is the CSV extension. Now I will be dealing with the data which will be the CSV extension. Later on I can deal with I will deal with data of ARFF as well, extension as well. So now I'm moving on to the desktop, and here if you see that there is a weather data data set. So this particular data set, if I now upload, I will show you that what are the different things which are special in this data set. Let us see what is special. In this data set, you will find that there are so many missing values, right? So I would like to show it to you in a familiar format of Excel format. Since I'm sharing the screen, I'm sure that you will be able to see the Excel format. So weather data set test, if I'm moving on to that, where it is, here it is, yeah. So let us open this and let us try and see that what is the data which is lying there. Weather dataset test, where it is, yeah, here it is in fact. So it is now getting opened in front of you. The first one, I have clicked on a wrong file, so this one is not that. I'm showing you with the Vika weather dataset. No, the weather dataset that I have downloaded, and the weather dataset that is having several values which are null values. That means missing values are there. So this is what is the weather data set which I was trying to show you. Oh no, just a while, I'm again opening it, and here is the weather data set which I will be showing you in a while. It is opening in front of us. Yeah, so as you can see here in the Excel sheet, you can find there are so many missing values, right? So now you need not worry about this. This data set can be very big. This is just for the demo purpose. There are only 14 rows. But then there can be 14,000 rows, and there can be 200 columns. So where will you go and find all these things? So either you can do it, impute these missing values by coding, or you can do it without coding. How to do this? Let us go to Weka. And now, as I have shown you, that this particular software, you see the missing values are evident here. Okay, so now if I would like to replace this missing values, what will I do? Let us do it easily by choosing a filter. So I will click on the choose button, and this drop down will open for me. I will click on filter now, and then click on unsupervised, then click on attribute, and try to find out that replace missing value. Yeah, replace missing value prompt. So where is that? So here is the replace missing values, right? So here if I choose a replace missing value, it will be reflected here in this browser. And what I need in this ribbon, in fact, and what I need to do is that I need to change certain parameters, only one parameter. That means ignore class is false, so that is true. If I make this true, then what will happen? Now I need to apply this. If I apply this and now go to edit, see, is there any missing value anymore? There is no missing value anymore. Now with this data set, you can do predictions, right? So with this data set, if you can do predictions, that what will be the hours played for a particular person. Now let's say if I would like to do certain kinds of prediction, let us select a data set. That is, if I would like to do a regression, let us see what kind of data set can we have for regression. That will be more familiar to you, or more seemingly more real time. So let's see if there is like any data for regression or things like that. Just for a while. Yeah. So here is a data set whose name is 50 startups. So let us see what is lying in this particular data set. This is the profit, which is the final Y column. Let us see it here. So R&D spend, administration, marketing spend, state normal, and profit. So finally, this is the cost for setting up a startup. So finally, how much profit will be there is being given here. So can we predict the profit with all these values? So how this is a the final y column as we see here is a continuous variable. So obviously this is something which is a regression problem. So let us move on to this classify tab and let us choose a regressor here. So what will be the regressor here? Let's say the regressor be linear regression. All right. So once we choose a linear regression and go for, let's say we go for a cross validation, two-fold cross validation, and let's start it here. So we get all these parameters. So what is this? How much correlation coefficient is there, mean absolute error? But then we are still wondering that what exactly are the predicted values, because these are more of mathematical and technical values. So we will be happy to see that what will be the predicted values. For that, what we need to do, we need to go to more options. And here, output predictions, we need to choose that we require the output as text. So plain text, if you choose it here and click OK, and then again you do this, you get the values now. You see, this is the actual value, this is the predicted value, not very bad. Yeah, so you find it here that what is the difference or the error which has happened due to regression, and all the values are being given here. All right. If you would like to have a visualization of this, you can also have that. So let's see how it looks like in visualization without doing any coding. So if I would like to visualize the classifier errors, I will go here and would like to see that what is the predicted profit in the x-axis and what is the profit in the x-axis. This is the actual profit and this is the predicted profit, right? So this jitter will actually increase the sizes of this of these plots so that you can understand it better. So this is how you will see the regression line is being drawn, and this is how the predicted profits are there. And let's say here the predicted profit is this and the actual profit is this. So this is the prediction and the actual value. Both the things are being given here. So if the line is going by like this, so you are getting this kind of regression value and visualization while you are doing regression. You can also change the axis and with different aspects and attributes which are given here, which will give you different kinds of visualization. So this visualization was essentially for regression. Now if I would like to do some kind of classification, so how can we do that with the help of Weka without a single line of code? So if I go to open files here, and I can have different data files in the Weka folder itself. I mean, there are several demo data files in the Weka folder itself. How can we access that? We need to go to again to the program files, and here if we go to the Weka files, we will be able to access those data. So once we go here, this is a data folder where you will now find that there are so many ARFF files. So I need to choose here the ARFF extension, and there are so many ARFF files. So I will choose the iris dataset here, which is a de facto dataset, and then you will find that iris data is having three different classes of iris setosa, iris versicolor, and iris virginica. What is this? Iris is a type of flower in which three different varieties are being chosen here, and these varieties are differentiated with the help of their sepal length, sepal width, petal length, and petal width, and the final class is predicted based on that. So if I would like to divide it into trend test, or I would like to do a cross for 10 for cross validation or whatever, then how will I do this, right? So let us go to the classify tab here, and now since as we see here, the last y column that is here, if you go, the last y column is discrete, not a continuous variable. So this is a classification problem. Once I come here to the classify tab and choose here, you will now find that I can do a SVM kind of a classification with, let's say, two-fold cross validation. If I do this, I'm getting this classification result with 94.67% of accuracy. And you see that all the metrics, popular metrics of classification, like true positive red, false positive red, precision, recall, F measure, right, ROC area, all these things are being calculated here for you. And also you are provided with a confusion matrix. What you can do that if you would like to save this result for future use, you can do a right click and can click on save result buffer. Once you do that, you can save it anywhere. Let's say you would like to save it on desktop. So for let's say you are saving it with the name demo result, and it is saved as all files. So if you are saving it on let's say on the desktop, and later on if you would like to see that how your result looked like earlier when you did the experiment, you just go here, make a right click, and try and open it with the help of a notepad, nothing else, nothing big thing. So I would like to open it with paid notepad, and you will see that how you will get back the previous results which you got in the real time and the run time of Weka, and you have saved it here on the desktop. So it will be now opened in the this notepad file for you in just the similar kind of visualization you are having here. All right. So I'm closing this one for you, also this one for you, and now you see this notepad is open for you, and the entire result is now being shown. So this is now being, see, all the predictions are here, everything are been given here. So your result is saved with all the values and the metrics. All right. So you get the entire thing which you have done if you save it for your later usage. If you would like to have it, use it in your experiments or in your report writing or anywhere, any place like that. So you can do that. Okay. This is how you can do classification. There are certain aspects of classification. You can do it by a supplied test set as well. So you can choose the test set from here. You can open the file and you can choose the test set, and then you can do a train test split kind of a classification. And you can also test your classification results on the training data only. Let's say if you are choosing this and starting this, so you are getting this kind of an accuracy, okay, on your training data itself with SMO. You can have different types of classifiers. For example, if you go to trees, you can have random forest classifiers, you can have LMT, you can have random tree. So if you choose a random forest classifier and start classifying with that, you will have different results. So it is giving you 100% accuracy on training data. But before that, SVM was providing you 96.67% of accuracy. So you can do a trial and error basis of testing based on that. Now, this is what about supervised learning. Now, you can also do unsupervised learning, that is clustering, with the help of this Weka without coding. So now if I move on to cluster, and you see, I can choose a data set and I can choose the different kinds of clusters. So I'm keeping the same data set here, which is this particular data set. This is the iris data set, and I will choose here classes to cluster evaluation. Why? So that I get to know that how far I have done it correctly. Okay. So now, if I choose simple k-means for clustering, I can also fine-tune it by choosing the number of clusters. As we already know here that there are three different, classes which are there. So let us see how efficiently it can divide the data in different clusters, right? Without knowing their classes, because as I have already told that clustering is something which is unsupervised. So let us see. So let us define the number of clusters as 3, and then let's say I click OK here, and then I start the clustering process. So you see 3 different clusters are being created, and cluster 0, cluster 1, and cluster 2. Cluster 0 corresponds to iris versicolor and thus iris setosa, and cluster 2 to iris virginica. So iris setosa, you see all 50 are perfectly in cluster 1. They are perfectly clustered. But then iris versicolor, 47 are clustered as iris versicolor correctly, but 3 are clustered wrongly. So what exactly these 3 are? These 3 belongs to whom? That is, these 3 are wrongly clustered as iris in cluster 2. They are supposed to be for iris versicolor. These 3 are iris versicolor, but then they are clustered in cluster 2 as iris virginica, as you can see here. And then for iris virginica, 14 are wrongly clustered again as iris versicolor. As you can see, it is below iris versicolor. So you see, for cluster 1, you are having 50. For cluster 0, you are having 61, 47 plus 14. And then for cluster 2, you are having 39. So it is giving you that how rightly or wrongly things are clustered. If you again would like to create one visualization for this, you do a right click and go here to visualize the cluster assignments. So here is the cluster assignment, and if I change the x and y axis as, let's say, uh, this is x axis with a class and y axis with a cluster. Okay, So this is actually showing me that how things are actually formed. So you see that this is what is the cluster 1, that is iris setosa, iris versicolor is cluster 0, and then this is the cluster 2, that is iris virginica. So if I click here, this is iris virginica, which is there in cluster 2. If I click here, this is for cluster 0. Iris virginica is there in cluster 0, which is wrongly clustered, right? And in the visualization, it is clearly visible. Why this is wrongly clustered? Probably it is more similar in looks, this picture, to the flowers in cluster 0. That is why it is wrongly clustered. However, this is how you can measure that how perfect or how great your unsupervised clustering algorithm is, with the help of visualization and with the help of this kind of results, which again you can save, as I have shown you, just like save result buffer, just like before, just like classification. You can also save this clustering results. All right. One more thing I would like to show you here is market basket analysis. You go to several shops, you go to several malls, and you find that there the different things which are being which are being stacked there, their combination changes. So on what basis their combination changes? It changes on the different types of joint transactions that are being made. That means with a cell phone, a cover probably will be bought. So probably cell phones and covers, cell phone covers, and probably the cover of the cell phone and the screen guard of the cell phone may be kept together, all together. So how they decide these things? With the help of association rules. So I will be showing you a priori rule with a data set whose name is the this particular data set, which is named as supermarket data set. So what all are there in the supermarket data set? Let's have a look. So these are the different things which are there, that is departments are there and different items are there, cheese and then salad, small goods, dairy food. So all these things are there in this particular data set. So once I go to the associate this particular thing and then choose, I can also choose a priori, I can choose a frigot, I can choose filtered associator, and the definitions are also given here. Once I keep this cursor here, it will be defined for you. So once I start this, you see what will happen. It is building the model for me, and it has built a model. You see that biscuits, foods, and fruit, which is having a high transaction value of 788, with which bread and cake are being bought 723 times. The confidence of predicting this is 92. The lift level. So different metrics which are there for the association rule are being given here, and all the rules which are generated here are are above 90%. So that means if you create this kind of a combination with this kind of rules, you are having the probability of having more and more transactions, sales, revenue, profit, right? So this is how machine learning is helping you in designing your store and designing your supermarket. But you can do this without even a single line of code, right? So there are other attributes, other tabs like forecasting, like select attributes. So you can do a trial and error basis kind of a thing with the help of this Vika software. So now I will move out from the Vika Explorer and I will show you one different function or one different aspect of Vika, which is known as Vika Experimenter. In Vika Experimenter, you will be in a position so that you can test that which classifier, which regressor is better for you. I'm showing it to you with the help of an example. So for that, I have clicked on Vika Experimenter and this window is opened in front of me, and I will choose on new. Once I choose on new, I will click on add new. Once I clicked on new, I will click on add new. Once I click on add new, probably I will be adding one data set. So here I will choose again the iris data and will try to understand that which classifier will actually do better classification for iris data. So I will choose an algorithm first. I will go to add new. I will go to choose classifier. Let's say I have chosen SVM classifier, and then I have added it here, okay, by clicking OK. And then again I will add another classifier. Let's say I will go here and go to trees and choose, let's say, random tree classifier, and then I will add this classifier as well. Once I do this, I will go to the run tab and will click on start. So once I have started this thing have started evaluating things for me. So it has finished the entire evaluation, and now I will go to the analyze tab. Once I go to the analyze tab, I will click on experiment, and I am now available results I will be able to see. So SMO and random tree results are here. So I would like to perform a test to find out that which one has done better, whether it is SVM or whether it is random tree. So I will perform a pair T test here, and I will click on the button perform pair test. You will see that trees have done a 93.27 level of accuracy, and for function, that is SVM, it is 96.27, which is better than this. But then these are not statistically significant different results. If it would have been statistically significant, then a star mark would have been there just beside these trees. So if a star mark is there beside your result, that means the variation in result is statistically significant. But here it is not statistically significant though, but there is a difference in result, and it clearly shows that SVM is performing better than random tree for this particular data set. Okay. So this is how you can test an experiment before using, even before using your classifier, that which one should you go choose for classification. So you can have this test done and can also have the results that whether it is statistically significant or not. Now I will show you one more type of experimentation with Weka by clicking on the Weka knowledge flow button. Once I click it, I will show you that how you can do it just by dragging and dropping. If you do not have that much of GUI knowledge, that is graphical user interface knowledge, how you can easily do it with the help of dragging and dropping. Now, this particular window will open as Weka knowledge flow environment, and I'm opening this in front of you. So first of all, what you have to do, you have to click on the data source, right? So once you have clicked on the data source, you can click here and can bring the ARFF loader here. So as I have shown you earlier, that you are having two different kinds of extension for loading the data. One is .arff format, another is .csv format. So there is also a CSV loader, C45 loader. So there are different sorts of loader which are here. Okay. So now once I have this ARFF loader, I will now load the data. I will now browse it, and let's say I'm again uploading the iris data, because this is small, simple, and it is easy to understand. And we have seen quite some time now the iris data. So once this iris data is loaded for me, what I will do is that I will try and find out from class assigner. Where from I will find it out? I will try to find it out from, let's say, classifiers. If I go, I will see different classifiers. If I go to evaluation, probably I will get it. Yes, here the class assigner is. So now I will find out the class assigner, which will show me, or which will show this entire algorithm, that which is the data and which is the class, which is the dependent variable and which is the independent variable. So once I get the class assigner, I will now select a cross validation folder maker, which will do the cross validation folder making for me. Now I will also need a classifier to carry out this classification. So let's say I'm choosing a random forest classifier from here. So where is the random forest classifier? It should be within trees, and here is the random forest classifier for me, which I'm choosing here. Now probably I would like to choose one more thing, that is classifier performance evaluated. All right, so this is what is the classifier performance evaluated. And finally, I will be choosing the visualization to see my results and the text viewer which I have chosen. Once I have done this, I need to connect all these dots properly. Now let's see how to connect this. If I do a right click, I will get this data set here, and I will get a ribbon like this, which I need to connect with the class assigner. As you see here, if you do a click, now it is connected. The data set is connected to the class assigner. Now you do a right click on the class assigner and then hit on this data set, and it will be now connected to the cross-validation fold maker. Now the cross-validation fold maker, once this is done, the cross-validation fold maker will be here for me, where I will find that I need to connect this to the random forest. So what to do? I need to connect both the training set and the test set here with the random forest. So it will show us that whether we are doing it correctly or not. So now we are having these two things connected. Once I have done this, I need to connect the batch classifier to the classifier performance evaluator. Now it is connected to the classifier performance evaluator, and now I will connect this particular thing, that is this particular evaluator, to the text viewer so that we can see the results. Once this setup is done, we can hit this play button so that the classification can be done or evaluated. Okay, if I hit this, you see everything is done properly. You can see the log here. If there is any error, you can find it in the log. So it is done correctly as it is showing here. So how can we understand that what has been exactly done? Let us go to the text viewer and click on show results. So here is the results for us. We see that it has been classified with random forest with 95.33% accuracy with all the metrics given here, right? This is the confusion matrix, which is also provided for you. And you see that how nicely it has been done without any line of coding. This type of GUI you can again get with Orange. This is another software which is there for you, which is named as Orange. Now, Orange will also provide you with a plethora of facilities without coding. Where can you get Orange? You can go here and can click or can type download Orange. You can also get Orange with Anaconda, right? Anaconda, if you download the Anaconda, then you can get Orange here as well. But then here, if you want to download it, because Anaconda is a heavy operation, so if you don't want to download it separately, you can go to this download Orange and Orange data mining download. You can go here, and once you enter this particular tab, you will find that Orange is now loaded for you. And download Orange 3. This is the latest version of Orange. You can click here for Windows and it will be downloaded for you. Once it is downloaded for you, you can have this kind of an icon on your desktop, on which if you just double click, you will go to this particular window. Now in Orange, let's say there are certain data sets, again just like data, you can have CSV file load, you can have this kind of file loads, this can be done. Okay, so this is what is the introduction of Orange. But before we start Orange, I would like to show you the final thing with Weka, that how can you even extract image features with the help of Weka. Okay, so now I have kept one image data, this folder for you. This is what is the data folder, which is having certain amount of images in categories, right? So this is the image test folder, this is the image data folder, where all the categories are here and the image labels are here in different CSV file. In a CSV file, what you have to do if you want to extract features of images with Weka, you have to keep the image files and the class in a image file name and the class in a CSV file. Okay, so now if I open the CSV file in front of you, what you will get to see is that all the image file names and their corresponding categories are enlisted here. All right, so now if I am opening it, that is the image level.csv, as long as it is getting open, I'm showing it to you with the help of the Explorer. Again, I have clicked the Explorer and the Explorer is now opening in front of us. Again, if you see here, I will open file and we'll go to image data, all right, to the desktop, and we'll go to the image data, and here I will look for CSV file, and now the CSV file is here for me. I have uploaded it. Now I need to change this nominal class, because this is not a nominal class, this is string, because this is the name of the images, right? So it has wrongly been interpreted as nominal class. So I will choose a filter from here, go to this place, go to unsupervised, go to attribute, and will from here, from where I will change this from nominal to string. So where will I get this? From nominal to string. I will get it here from nominal to string. Once it is here, I need to do a little bit of fine tuning. Since this is the first one, I need to change this to first. This is the first attribute, isn't it? So I click OK here and then apply it here, and you see this has been changed to string. Okay. Now what I will do is that I will choose the image folder path. So for that I need to choose the image filters. I will go to instance. I will choose image filter from here. Let's say I am choosing color layout filter. Okay. So now if I have chosen the color layout filter, I need to just replace the path of the image folder in this image directory ribbon. Okay. So once I go here, wherever the image is, I will copy the path from this place and I will come here, in fact here, and I will paste it here. Okay. Now, once I get it here, the image data, I will just click on OK and click apply here. And you see the feature is now getting extracted and it is now extracted in front of you. Here are the features, right? For you, let us see what has been extracted. So these are the features which are being extracted, okay? And these are the categories which are automatically being given there based on the file names which are here in the Excel sheet, which we have already provided. So now what we require for classification task here is that we require these features and we do not require the image names, right? So what we can do is that we can just remove this file so that we can have our features ready along with the class. That is this category, all right? So we can directly go here, come here, and can choose a classifier of our choice. Let's say we are choosing a classifier, a random forest, for example, which is a popular classifier. And let's say we do a 5-fold cross validation with the data, and let's start here. So we get a 65% accuracy with random forest classifier and all the metrics with the confusion matrix is being shown here for your reference. You can save these results. You can have the visualization of this classification to visualize classifier errors. So these are the actual class, these are the predicted class. If I increase the GTED, you can see that how these are rightly or wrongly classified, right? So now, this is the last thing I was showing you from Vika. The same things you can do in Orange. Let's say in Orange, if you are coming here and if you are being shown with, let's say, you need to replace the missing values. So let us go to file, CSV file. And if I bring the CSV file here and then click this, the CSV file will come here, okay? So let's see how the CSV file comes here. Meanwhile, let us move out from Vika. So Vika now is moved out, and now we are having only Orange in front of us. So we are having the CSV file import, which is running 100%. Let's see what is there in the CSV file and what data we can upload here. Okay. So if I double click on the CSV file, once I double click on the CSV file, I will be able to upload data. So this weather data.test, which I have shown you, I will now upload in the CSV file. What I have uploaded, I can see here with the help of the data table. So if I link this, if I link this to the data table and click on the data table just a while, if I link this CSV file to the data table, I click here, I will see that there are so many values which are there, which are missing values, right? So if I need to fill up this missing values, then I could search for one particular impute, right? So impute, this particular interface is now here. I will just connect it to impute, okay? And let's see what the connection has been done. So for the entire data, I would like to do this, not on the selected data. Okay. So the imputation, I guess, is being done. To see that whether it is done or not, let us connect it to another data table and let us see. So you see all the values are now imputed. There is no missing value. Earlier, we used to have missing values. These are the missing values. But as soon as we got it connected with this impute, all the values are now replaced with the imputation function, and there is no more missing values, right? So we can do predictions with the help of this data, as I have already shown you in Veka. Now let's say we would like to do some kind of classification task with Veka. Okay, so let us now move on with the classification task and let's see how it is being done. There are data sets again in orange for you as well. So now if I data sets which are there from here, if I select a particular sort of data set, let's say if I select a categorical data set, here is a breast cancer data set which will predict that whether there is a cancer or not. So I have selected this data set, and with this data set, now if I would like to see that what exactly I have uploaded, let us see it here, and here it is being shown that this is what is the now these are the different types which are there, right? This is state. Okay, so these are the categories which I can predict. All right, so now let us select all of this, and let us try to do a classification job. So how can we do that? We need to select the column for dependent and independent variable. Let us see whether that is selected or not. Yes, this is state is a dependent variable, and the rest are the independent variables which are predictors, right, for the this is state. Now once we do that, what we will do is that we will choose a model for classification. But before we do that, we will choose an evaluator. So we have chosen test and score. So let us connect this to test and score. Okay. Now we choose the evaluator. Let us choose a SVM evaluator for this, and the SVM evaluator is now here. And then I connect this data to SVM. Okay. So once this is connected to SVM, I need to also connect the test and score function to SVM. That is this function to SVM. Let us see if I connect this to SVM. So not in this way, but here I need to connect. And now once it is getting connected, it is taking a little bit of time. Let's say from here, if I connect it to this place, sorry, from here, if I connect it to here, to SVM, okay, sorry. So let us connect it like this. So it is a learner, and you see, the SVM is now connected to test and score, and it is now trying to find out the results. Okay. So you see the test and score is running, and it is 0% now, and it will increase for a while, 33% now, and then it is actually doing the classification, and the results will be displayed in front of you in a while. Let us see as soon as it, because the data is quite big, and that is why probably it is taking a little bit of time. Meanwhile, we can have the visualization with the help of a confusion matrix. Where is the confusion matrix? Now, the confusion matrix is here in front of us. Let us see where is the confusion matrix for visualization. So, here it is, I guess, the scatter plot, distribution, box plot, previewer, heat map, linear projection, model. Yeah, here is the confusion matrix. Now here from the test and score, let us see what are the results. This is the result where we get a precision of 77.772, a recall of 0.625, F1 score of 0.517, AUC of 0.829, and such that. So let us see what has gone wrong or what has gone right with the help of confusion matrix. Let us see the results. So this is what is the result, right? So this is what we are having, the summation and the confusion matrix, proportion of predicted, and this is the proportion of actual. Okay, so this is how we can get into the classification task. Now one more thing is that how can we extract features from images even here, right? So that is very simple. We need to click on import images. Here we do not have to keep any sort of Excel file. We can directly go here and can upload the image test folder. It is now uploaded here, and then what we can do is that we can select the image embedding, and in image embedding what we can do is that with the help of image embedding, we can extract the features with the help of different pre-trained convolutional neural network. So let's see how it works. Like for example, we have selected the image embedding. I don't know where it has gone. Yeah, there are so many image embedding now here in front of us. So let me choose one, this one, and let me erase it, and let me bring it here. So I have brought it here, and then connect it to image embedding, and now it is extracting feature for me. So let's see what has actually been done with the help of a data table. So once I connect it to the data table, I will try and find out, see, these are the different metadata for the image, that is the name of the image, the path for the image, the size, the width, and the height. These are the categories of the image, and then you see these are the features which are being extracted for the image. So what we find on the whole, there are almost 4096 features which are extracted for the image. Now, if I would like to go for a classification, what I will do, I will again do the same thing. Let's say I have chosen random forest this time, and then I will choose one model of evaluation, that is test and score. And if I connect this to this, and in fact, not the selected data, there is no selected data, I need to do it with the entire data that I have. Okay, fine. And then I have done this, and I need to connect the data with this as well. And now with the random forest is connected, I need to connect this to this as a learning. Now you see the test and score is running for us and is about to show us the results. Now 66% is already being done. Let's connect the confusion matrix so that we can see what our results are. So let's connect it, the confusion matrix, and see this is how these things are being classified. So the first two are classified correctly, and the monument and sea beach are having one each wrong correction. So one wrong classification in each case of monument and sea beach. So almost the classification results are very nice. Let us see what is the result. So 95.2 precision, so 0.952, and recall is 0.95, and reference score is 0.95. Okay, and AUC is 0.992. The precision is quite high here. If you would like to see what has gone wrong, then we can easily choose one image viewer, let's say, and where the image viewer has gone, here it is, and we can connect this to the confusion matrix. And let's say if I would like to see what has gone wrong with this, why monument is classified as sea beach, let us see what this image viewer says. So this monument is having more and more blue here, so probably it has got classified as sea beach, right? So if I would like to see the next thing which has gone wrong, which is why the sea beach is classified as human beings, let's see here in the image viewer. So here it is showing so many people are here. That is why the machine has wrongly classified the sea beach as human beings. Okay, so this is how you can do with the help of Orange software as well. And just the way I have shown you for the Vika, here also you can do clustering. Here also you can do unsupervised learning. Like unsupervised learning is here. Here you can also do feature dimension reduction with the help of different tools like PCA, that is principal component analysis. So I'm showing you one example for PCA. Let's say here is this particular data. So what is the data set? This data set is like this. So here is the data sets which we are having for Orange. It has must is here. Yeah. So now if I select some kind of a data from here, sorry, some kind of a data from here, what kind of data shall I choose? Let us choose the wine data set. So now if I choose a wine data set from here, right here the wine data set has been chosen. And if I would like to see that what are the different columns of this wine data set, if I connect it here, I will see the different columns of wine data set, which is like this, right? These are the different columns. So there are so many features for wine data set. So if I would like to see that how good these features are for classification, I can connect this to a scatter plot, and I will see that how good these features are differentiating the three different classes of wine. But why I'm saying this, you can see there are three different classes of wine. This is class 1, and then as you see this is class 3, and then as you see this is class 2, the features of class 2. Okay, so let us see how good it is actually being differentiated. Okay, so like in this data table, what we see that these are the different data which we are having. And in the scatter plot, you see these data is almost haphazard. These are overlapping, isn't it? Now if we try to find out the principal component analysis of this, probably we get higher significant features and feature dimension reduced as well. So how do we do that? We will select this PCA from here and we will connect it to this. Okay, so where is the PCA? Here is the PCA. So once we get the PCA tab here in front of us, what we will do is that we can connect this to PCA. Okay, so once this is connected to PCA, we will find that you see almost, if I take up to 5 columns of the data, original data, it is having a cumulative variance of over 80%. So it will be good enough for segregating the data. So now, if I connect it to another scatter plot for that matter, let's see, here is a scatter plot and how good are they connected. So what are the principal components that have been extracted? Let us get connected here and see what are the principal components. So these are the different PC1, PC2, PC3, PC4 and PC5. These are the different principal components which have been extracted out of this. Okay, and like if this principal components, if I would like to see like what is the transform data, I mean how the transform data looks like. So if I look here, so I will see that PC1, PC2, these are the only 5 things which are categorizing this. Okay, so instead of these entire features which I am having, I can do it with just these 3. Okay, so let us do it, and let us connect it to the scatter plot. And once I connect it to the scatter plot, let's say, so let us join it here to the scatter plot, and let us see how good or bad the data is now classified. So for that, we need to select it. And once these all are selected with Control A, you see only with these 5 components of principal component, how good the data is now classified. This difference is visible. No, you see this is the first one with the usual features, and this is with the principal component extracted. So how good it is now differentiated. So like this, you can also do clustering and stuff like that without coding with Orange, Vika, with the Teachable Machine, web browser, which I have shown, and I'm sure you will be able to look at many more.
If you found this tutorial helpful, like this video, subscribe for more AI tips, and share it with a friend. Check the description for links to our Udemy course for automating your daily tasks with generative AI, and I'll see you in the next video.